Zhang, and today I will present a collaboration project with Goldman, integrating the heterogeneous data source to enhance trading strategy in the commodity future market. And let's start from some background, the pair trading. And the pair trading is a market-neutral strategies that explore the relative mispricing between two assets. And here I use an example to show how the pair trading can get a profit. And in general, we assume two assets are highly correlated. When we observe some price divergence between the two assets, the shade area means the spread between the two assets. And this means one asset is undervalued and another one is overvalued. So once we observe such point, we long one asset and short the overvalued assets. And with time goes by, the price revert back, and then we exist a long-short trade. This is how the pair trading get profit from markets. And next, I will talk about the Chinese commodity market. And the Chinese commodity market is a leading producer and consumer in the commodity markets. And it has a large trading volumes every day, and also high liquid markets. And also in the Chinese commodity market, this allows both the long and the short position. So such market provides a perfect environment for the pair trading and arbitrage strategies. And however, different with the mature Western markets, this market is heavily dependent on the policy and so some domestic factors. And also, this market is heavily dependent on the global markets. And this figure shows the import relative to demands of the Chinese commodity markets. And so, the current methods mainly depend on the traditional static methods and the model machine learning methods. And the static methods generally, in general, they will analyze the spread between the assets and then generate the fixed threshold. This cannot be adapted to the dynamic markets. And another, the modern machine learning methods generally treat the spread as time sequence data, and then use the GRU, RN, or LSTM to do the trend prediction. However, this is not the real decision, just predict the trend of the spread. And because it's quite hard to define proper trading signals for such data. And so, besides, another key problem is the current methods only consider the single source data information, only the price information of the assets. And however, as we mentioned before, the microeconomic data in the domestic policies or some cross-market signals are also very key for this trading strategy, as shows the heat map of the correlation between the Chinese commodity with the micro indicator in China and the US commodity futures. And we can observe a strong correlation between such signals between different domain data. And finally, we hope we can propose more natural and advanced way for pair trading. We target on the profit and not just do the prediction of the trend of spread. And we also hope we can do some risk-aware decision. And so motivated by this, we propose a dual-stream reinforcement learning framework. And in this framework, the agent can interact with the environment. The environment contains both the price information and also different domain information, such as the economic indicator or the US market information. And then the agent can adapt itself to the different source domains information in the environment. And also, this we needn't manually define the reward. The agent can optimize the reward directly, such as we can define some financial metrics, the portfolio or Sharpe ratio. And also we can manually define some actions, risk-aware actions. We can consider both the caption risk constraints or incorporate some stop loss to make sure this process is stable. And finally, as for the key part is the agent, how we design the agent. And we use a dual stream network structure to encode different source domain information. And I will not talk too much details here. And if you are interested, I also share my paper link here. And finally, I show the experiment part. And here is how we do the time simulation of we use 10 years data, and then we use the formation and the training period split as shown in this figure. And the experiment results just evaluate our model can get better performance in both the profit and the stable. And also, we realized the trading signal here. And if you are interested in the paper, please refer the link, and you can scan the QR code. And so that's all, and thank you.
Thank you, Li Zhang, for the short talks.